Hello and welcome to tutorial 14. Now, this is the final tutorial in this VR VEX series. Now, in this tutorial, I'm going to first share with you the solution to the 12th and final challenge, which was posed in the last tutorial. Alright, the challenge was to start from here, and then with your pen, draw a square spiral, and obviously it's supposed to move towards the center, and as you come to the center, you would eventually stop. Alright. Now, this is how I wrote my program. Alright, so I started with the maximum velocity. Then I created a variable called distance from the edge, which is basically the distance from the front face of the robot to the edge. Okay, so I set that as 50. Okay, I'm going to explain that in a bit. Okay, and then after that I started my robot pen to move down, set it to the color blue. Okay, so I've got that. Now, all that is not going to be put into action until this step is actually asked for. Okay, so this is the driving forward. Only when it drives, then the pen starts to draw, remember. Okay, because the pen is attached to the robot. If it does not move, the line is not drawn. So the color is blue. Now, this is the important condition. Okay, it says, while the robot is not in this position, do this. Okay, now what is the position? I'm just going to bring this down a bit. The position is between 0 and negative 50 for x, 0 negative 50 for y. So while it's not in this position, so 0 0 is here. This is the negative for x, this is the positive for x, this is the negative for y, positive for y. So 0 to negative 50 for x would be somewhere here, 0 to negative 50 for y would be somewhere here, which actually means while it's not in this position, which is basically almost at the center, then you do this. And what is it that you do? You drive forward for this distance, which is 1008, which is the maximum, minus the distance away from the edge. Okay, so that's the variable I'm talking about, and that variable would actually increase by 100 every time the cycle is completed. And the cycle is basically two movements or two repeats of this movement, which is driving forward, turning right. So that's my first cycle. Second one is forward, turning right. You realize the same distance is repeated twice, and then the next distance would automatically become shorter, which is because the variable, the distance from the edge, is actually becoming greater, okay, by 100. And you need that to happen in order for the robot to move inwards. Okay, this variable has to increase. All right, and eventually, once it reaches that position, which is between 0 to negative 50 of the x-axis and the y-axis, it will stop moving. All right, so this is the program. Let's see how this works out. Okay, I'm going to move back to the original position, and I'm going to play it. All right, and as this is moving, you see the x and the y coordinates changing. Okay, it would get closer to 0 as it moves inward. All right, so you see it's moving inward now. Okay, it's moving inward. Okay, the distance that it's moving is also getting lesser. All right, now take note that the change in the variable, which in this case is 100, now you could have it lesser, 50 or 30, but if you do that, the distance between these two lines is going to be lesser. So your square spiral would actually be more dense, you'd have more lines, and it will take a longer time for you to get to the center. You could do that, so it doesn't have to be 100, it could be 80, 70, 50, 60, but it would just take longer, and you'd have more lines. All right, so some of you might have a different value here. That's perfectly fine. Okay, now while waiting for it to come to the center, okay, let me just show you some of the things you could do, because this is really the last tutorial. I'm not going to give you any more challenges, but I'm going to show you some more challenges you could embark on your own. Right, so this is a dynamic wall maze. You could find it here. We've all tried the wall maze. Okay, so how is the dynamic wall maze different? So this is similar to the maze that you saw, okay, but the layout is different. Now in this dynamic wall maze, every time you press refresh, see what happens? Your maze layout actually changes. Okay, every time I press refresh, it changes. So you got to come out with an algorithm or a program, okay, which doesn't have predefined distances. So you can't have predefined functions which actually just has predefined distances in them. You got to use your sensor, your distance sensor, to somehow spot obstacles. It's not very difficult, looking at the fact that the wall is always red. All right, so think about it. All right, you can always also use your bumpers. So these are basically your bumpers. So once the bumpers are pressed, which is not something that I've covered, but you can easily try and figure out how those work. Okay, so use your bumpers and then use your distance sensor, your color sensors to solve this. Try this out. This is really challenging. Then you've also got something called the castle crasher. All right, the castle crasher is where you've got a castle and some of the towers around it. Okay, your aim is basically to crash the towers and the castle out and make them fall out of the grid. Sorry, it's not a grid, but fall out of this plate. All right, so that's the castle crasher. Okay, obviously you need to use a distance sensor. You can also get a dynamic version of this, which makes it harder, obviously. So similar to the dynamic wall maze, the position of the towers and the castle keeps changing. All right, so these are two challenges you can try. There's more challenges here. You can use your art canvas, where basically it's just like a blank canvas. You can draw whatever you want. You can draw your initials. You can draw anything you want, basically, using the different colors that you have, using your robotic pen that is attached. All right, now let's get back to the problem earlier. Okay, it stopped moving as I was explaining those things. But anyway, it should reach the center now. Now it hasn't reached. Remember the negative 50, 0 to negative 50 for both x and y. And once it does that, it is then going to stop moving in square spiral. All right, so we're almost there. These are getting closer. All right, almost there. Almost. All right, there we go. There we are. All right, so we're done. We're at the center and stop moving now. Okay, so we've managed to do this. Great job. Wonderful job. This wasn't easy. Okay, now, like I said, you can try out the other challenges. All right, this is the last tutorial. So from now on, you're on your own. Go and try other challenges down here, and all the best. Thank you very much for tuning into all the 14 tutorials. All right, I hope you enjoy your time trying out all the other challenges that you have and venturing into the other playgrounds that we have here. Thank you very much for listening. Goodbye.